Change of plans. I try to run through the math quickly on how to calculate the number, how much the wager depending on Bernoulli's expected value being equal to my current wealth, which is equal to $20,000, and it was impossible, more or less impossible for me. So we will do that later on. Um, right now, what I'm gonna because what Spitznagel then goes on to show us is this really cool thing where he connects the geometric average to the calculation of the emolumentum medium using log rules. And that simplifies stuff. Once we get through that, then we'll be able to calculate how much someone with $20,000 in wealth would wager to play this game, the minimum that he would have to spend. Um, just to quickly show you, so in the actual book itself, where is it? Yeah. So what he does is basically, first he shows you the bunch of different calculations that you can wager, and then he just um, puts it on a grid. So we won't do this. He doesn't show us the math behind this. What we'll do instead is we will calculate the number. But that's for another video. Now what I want to show you is how to simplify all of this. This is an issue because, of course, it takes a lot of time to calculate each one, and it's hard to do it. So what Spitznagel points out is that it's actually quite easy to simplify, and when you do it, you realize that you're actually calculating the geometric average. So let's actually take that square of information and use it in the next part. Copy, paste it. So the point that Spitznagel makes here is that the geometric average is equal to the emolumentum medium. So if you wanted to calculate one, you could calculate the other. And how is this true? Well, you line up all of your terms here, you calculate them, but you can also simplify this a lot. So first, you can use the addition log rule, I believe it is, where when you are adding two logs together, the term inside of it can be multiplied together. So instead of that, we can simplify it to 19,981 times 19,982 times 1996 times 2002 times 2180 times 1,019,980 divided by 6. Another way of writing divided by 6 is also to multiply by 1 over 6. So like this, 1 over 6 multiplied by that. Okay, so now we've done the first, we've used that, the first rule of logs. The next thing that we're going to do is something nifty, where if you're multiplying something, then you can also turn that into the exponent of, if you're multiplying a log by a factor, you can turn that into an exponent of the log. So what that means then is, I'm just going to calculate that number out because no, I won't, it's too hard. I will take this 1 over 6 and I'll move it to the exponent place right over here. And so then it becomes a nice, beautiful times 1 over 6. And now, that's how you calculate the emolumentum medium. It's a simplified version here. But the last thing that we want to get rid of is the natural log. And if you recall, once you calculated, so before in the last video, once we calculated the emolumentum medium, to get it into a dollar value, what we had to do is plop it into the exponent part of the Euler's constant, Euler's number, and only after we did that could we calculate Bernoulli's expected value. So if we were to calculate Bernoulli's expected value, what we could do is, what we would be doing is, that's how you calculate it, right? So what you need to do then is you take this number and you put it in the exponent, right? So then it becomes natural log or ln 1990 blah 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 raised to the power of 1 over 6. However, when you do this, you realize that when you raise a log, or when you raise a number to the log of another number with the same base, just like here, then these two cancel out and you're left only with the term inside the log. So what that means then, since ln has a e here, is that these two things cancel out. And you're left only with the terms, which is equal to, 19,981 times 19,982 times 19,986 times 2002 times 2180 times 1019980. The ones we mentioned here, right? And then you raise that to the power of 1 over 6. Now, this should be blowing your mind because this is the geometric average. It's the exact same thing. That's exactly how you calculate the geometric average. So you can calculate, this is wrong, by the way. It's actually Bernoulli expected value. You can calculate your Bernoulli expected value by looking at the geometric average of the possible wealth outcomes that come, and then using that. Okay, which is quite mind-blowing. So that's how you calculate your Bernoulli expected value really quickly. You take your ending wealth outcomes, you multiply them by each other, you raise it to 1 over the number of terms that you have. And that's a shortcut for calculating your Bernoulli expected value.